Here is a question from Namrata Soni, and the question is, an HCl molecule has a dipole moment of 3.4 into 10 to the power minus 30 coulomb meter. So, you have HCl molecule, and you have electron clouds, and this molecule has a dipole moment of 3.4 into 10 to the power minus 30 coulomb meter. Now, assuming that, this is a very important word, assuming that equal and opposite charges lie on the two atoms of the and they form a dipole, what is the magnitude of these charges? The separation between the two atoms of HCl is 1.0 into 10 to the power minus 10 meter. So, this separation center to center, nucleus to nucleus, this separation is given 1.0 into 10 to the power minus 10 meter, and you assume that you have minus plus q and minus q charges on these atoms. So, assuming that equal and opposite charges lie on the two atoms and form a dipole. So, that is the assumption, and then you have to find the magnitude of these charges. You have to find this plus q and minus q, but that is not the question, because the answer is also given here, and the answer is 3.4 into q equal to 3.4 into 10 to the power minus 20 coulombs. And the question comes now. Then the question is, this is less than the charge of proton, how such charge can appear on the atom, right? This charge q, which is the answer of this question, plus q minus q, where q is this is less than the electronic charge or proton charge, which is E equal to 1.6 into 10 power minus 19 coulomb, and you cannot have a charge on any object which is less than this, or a fraction of this, or non-integral multiple of this. So, the question is how this is possible. Now, first thing is that the question does not say that it is the charge on atoms. It says that assume that you have plus q and minus q. Under that assumption, what is the value of q? It is not how much charge is on this H and how much charge is on Cl. So, that is the safe answer. Now, why this question was formulated first of all, if it is so unphysical? There is some justification for this question also. The electrons which are there, chlorine electrons and hydrogen electrons, and especially those outer electrons of chlorine and then that hydrogen electron, they all form some kind of a cloud. In the sense, you can model it this way: the electron is moving here and there. So, all these electrons together because of that movement make some kind of a cloud. So, you have electron negative charge which is distributed over this whole volume, and then you have positive charge here and positive charge here on the nucleus. And this whole thing, if it is distributed in such a manner that together with these plus charges, the whole thing is symmetric and there is no dipole moment, in that case there will be no dipole moment. But if this distribution is not symmetric, if it is shifted, and it is shifted very slightly, so you still have electrons and electronic charges, but the whole thing which looks like a cloud, if that is shifted slightly, then you will have a slight positive charge on this side and slight negative charge on this side, and that will create a dipole moment. And that charge which seems to appear here and the charge which seems to appear here, that is this plus q and minus q, and that is smaller than this E, because the electron E, there are so many electrons, they are all moving and they are slightly shifted, and therefore, if I look at this positive charge here on the nucleus and the electron is slightly shifted on that side. So, here you have a slight negative charge appearing, here you have a slight negative charge on chlorine and slight positive charge on hydrogen. And how much is that charge? It is not because of a particle sitting there, charged particle sitting there. The whole electron is spending less time here and more time there. That is how this charge is appearing here and there, and that can be less than this electronic charge.